This video is an introduction to our recent work, SP2T, which has been accepted by ICCV 2025. The audio of this video is generated by Quen3TTS. We start from a key observation. Simply enlarging the receptive field in point transformer V3 can blur fine-grained details. Proxy, which serves as abstract representations for simplifying feature maps, enables global RF. However, existing proxy-based approaches face critical limitations. Global proxies incur quadratic complexity for large-scale point clouds and suffer positional ambiguity, while local proxy alternatives struggle with 1. Unreliable sampling from the geometrically diverse point cloud, 2. Inefficient proxy interaction computation, and motor end, 3. Imbalanced local-global information fusion. Our method addresses these challenges with 3 ideas. First, spatial-wise proxy sampling that's robust on diverse shapes through vertex-based associations. Second, sparse proxy attention, which enables efficient point-to-proxy and proxy-to-point interaction using table-based relative bias. Third, a dual-stream design that learns complementary local and global representations, striking a better balance than single-stream models. Together, these yield strong accuracy with practical efficiency. SP2T is a dual-stream network designed specifically for point clouds. After spatial-wise proxy sampling and vertex-based association connect points and proxies, the model extracts features through several SP2T layers, each made of multiple SP2T blocks. These blocks enable efficient information exchange between the point and proxy streams. Finally, up or down sampling modules refine the point and proxy features, producing a balanced representation of both local details and global structure. Next, I'll explain the 3 key components that make this architecture effective: the spatial-wise proxy sampling, vertex-based association, and sparse proxy attention. Common sampling choices each have pitfalls. FPS can become scene-biased and overfit. Uniform grids may distort or produce unstable proxy counts as geometry varies. Our spatial-wise sampling performs a binary search over proxy spacing to achieve uniform, stable, and efficient proxy placement across scenes. This means the proxy set adapts predictably as density and scale change, crucial for indoor rooms, outdoor streets, and everything in between. Associating points to proxies with standard KNN is flexible but expensive. We instead leverage the grid structure and use L-infinity KNN with k equal to 8, which corresponds to the 8 corner proxies of each point's axis-aligned bounding cube. Operationally, we map a point to the grid, find floor and seal neighbors, and build the association list without full distance computation. This preserves flexibility while keeping costs low and associations geometrically meaningful. With associations in place, sparse proxy attention handles the discrete many-to-few interactions between points and their connected proxies. Instead of dense attention over all pairs, we only compute on the linked set, accelerating information exchange in both directions. We further adopt a table-based relative bias and implement the kernels with GPU warp code for high throughput. The result is scalable attention that respects geometry and budget. For experiment, we evaluate across indoor semantic segmentation, indoor instance segmentation, outdoor semantic segmentation, and Waymo object detection. Our method achieves state-of-the-art performance on both indoor and outdoor benchmarks and delivers especially large gains compared to prior proxy-based method. To build intuition, we first visualize attention in 2 directions: point-to-proxy or proxy-to-point and point-to-point. Point-to-proxy or proxy-to-point maps show how local details select structurally appropriate proxies. Point-to-point maps reveal how global representatives distribute contextual cues back to relevant regions. These views confirm that SP2T routes information sparsely and meaningfully rather than diffusing it everywhere. Here we compare ground truth, PTV3, and our method. SP2T better delineates object boundaries and fine structures while keeping global consistency. For example, separating adjacent instances, preserving thin parts, and avoiding oversmoothing in large receptive fields. These improvements are consistent with our design goals: retain detail locally, reason globally, and communicate efficiently through sparse attention. Summarize: SP2T is a framework for robust 3D understanding that combines spatial-wise sampling for reliable proxy generation on diverse geometries, sparse proxy attention for efficient feature exchange between points and proxies, a dual-stream transformer for balanced local-global learning. For future work, we plan to explore parameter tuning, dynamic proxies, and refining the dual-stream balance to push accuracy-efficiency trade-offs even further. Thank you for watching.